how to use the HURWITZ criterion, and we need to investigate the stability of closed loop control system. Investigation for a closed loop control system, stability has to be done. So let me know the characteristic equation is given. Characteristic equation is S6 plus 2S5 plus 8S4 plus 12S cube plus 20S square plus 16S plus 16. So this itself is a characteristic equation and has been given in the question. So we'll form the root height. How we have formed root height? We already discussed this. First rule we have to write. Maximum is s to the power 6. This will be s to the power 5. So first term is 1, 8, 20 and 60. Okay. The second is 2, 12 and 60. And this is 0. So 1, 8, 20 and 16, 2, 12 and then 60. So now next we have found the S4, S is power 4. 8 into 2 is 16, 16 minus 12 is 4, 4 divided by 2 is 2. Okay, 8 into 2 is 16, 16 minus 12 divided by 2, 4 divided by 2 is 2. 20 into 2 is 40, 40 minus 16 is 24, 24 divided by 2 is 12. 40 minus 16 is 24, 24 divided by 2 is 12. Okay. 32 minus 0 divided by 2 is 16. S cube. 24 minus 24 divided by 2 is 0. 32 minus 32 divided by 2 is 0. Okay, then we don't have it. Okay, so now this is called rho of 0. Rho becomes prematurely 0. You should always remember that in any roots table, rho of 0 will be always on the odd power surface. This can never be on the even power surface. You take any root table. This is a universal truth. Note it down. This is required in the, while we are solving the numericals, this point will be required. So it becomes prematurely 0. Now what we have to do? When this row becomes prematurely 0, you get 0, 0, 0. Now what we have to consider? We have to consider auxiliary equation which will be above this row. Auxiliary equation which will be above this row. And we have to differentiate that auxiliary equation. Once we differentiate it, whatever the coefficients of differentiation will be there, that has to be replaced by these zeros. I'm going to repeat it again. We have to consider an auxiliary equation which is above the row of 0. How we have to consider that? That will be 2s4, 12s square and 16. We have to differentiate it. Whatever coefficients will come, that has to be replaced here. So we can write down first. Since row of 0 becomes prematurely, row of 0 appears prematurely, appears prematurely, we form the auxiliary equation, we form the auxiliary polynomial using the coefficients of S4 row. Using the coefficients of S4 row. So therefore, auxiliary equation will be represented as A of S will be 2s raised to power 4 plus 12 s square plus 16. Now then we differentiate this auxiliary equation with respect to the independent variable, that is s will be 8s plus 12. Okay, now then what we do, we differentiate this by the independent variable, that is s, and get 8s and 2. Replace these two. Yes? Yeah, fine. I'm not worried about the variables. The difference in I know ns and raised power n minus 1, I know that. So I'm not worried about the variables, but whatever the rule is there, that has to be there. I'm worried about the constants. So I need to replace this constant.
24.
Oh, this is wrong. That should be, yeah. This is correct. So we have to replace these two coefficients. Where will we replace this? We have to replace this here and here. So what the first coefficient s cubed will come out to be 8. Then is this happens when you become a teacher and you are not calculating much mathematics, then what happens? You won't do this. Anyway, that's regrettable. 8 and 24 we have replaced. Fine, we have replaced. So what we have done, we have taken off. When the row will become, when row will appear, naturally 0 will become 0. Then what we have to do, we have to take the auxiliary equation. Know that auxiliary equation is taken in the same. This should be s4, this should be s square, and this should be s0. Anything is possible is 1. So we have taken that, differentiated it with independent variable, that is s. We are going to get 4 into 2 is 8, 8s cubed, 12 into 2 is 24, 24s. And constant is 0. So replace these coefficients here. Now again form the, continue to form the root array in the similar manner. So 12 into 8 is 108. 16. Yeah. 12 into 8 is 96. 96 minus 48 is 48. 48 divided by 8 is 6. I think it's correct. 96 minus 48, that is divided by 96 minus 48 is 48. 48 divided by 2 is 48 divided by 8 is 6. That should be 6. Fine. Next, 16 into 8 is 108. Yeah, that should be 108. 108 minus 0 divided by 8. That should be 16. Fine. Should be 0. Next, S1. Okay. 26 into 6 is how much? 24. Sorry. 24 into 6 minus 108 divided by 6. So that should be 8 will go 36 by 6. That should be 6. Yeah, again 6 here. Okay. 6 minus 0, 0. This is everything is 0. And this will be copied here. How? 16 into 6 minus 0 divided by 6 will be 16. I hope this is fine. Okay. 8, 24, 6, 16, 6 and 0. Oh, something is wrong. 6 and 16 is fine. Then this is how much? 24. Yeah. 6 4s are 24, 6 2s are 14, 6 2s are 12, 12 and 2 is 14. That is 144. Should be 96. 16 into 8 is 96. 48 and कितना 16 into 48 plus 12 120. Sorry. So how much is this? 12 and 14. This is 16. 16 by 6. That is 8 by 3. 8 by 3 and 1 should be 16. Yeah, it should be 16. Please do not take this. Okay, so now again, what is all? If we talk about the investigation of the stability, there is no problem, there are no sign changes in the first column. We can say this is positive, 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 and positive. So when there are no sign changes, there are no roots on the right half of S plane, the system is stable. So this is a very simple concept. But there is something more to be discussed here. Now once we have a row of 0 and we have considered the auxiliary equation, with the auxiliary equation, we'll substitute that auxiliary equation equal to 0, we are going to get 2 roots. So how we are going to get 2 roots? We can write down this one. From the above equations, so procedure, remember it. From the above equations, the coefficients of above equations mean these two equations we are talking about. The coefficients of the coefficients 8 and 24 are replaced in the row of zeros, bracket में s cube row. In the row of zeros, bracket में s cube row of the original tabulation. Thus, or you can write down then the calculation of the root array is formed in the usual manner. Then the calculation of the root array is formed in the usual manner. So this is about row of zeros. Next, since there are no sign changes in the first column, of the entire root array, hence there are no roots in the right half of S plane, and system under investigation is a stable system. Okay. Now let's have an auxiliary equation now. This is not asked in this question, but sometimes may be asked in the gate examination. Normally this is asked. Let's substitute this auxiliary equation equal to 0. What's an auxiliary equation? This is auxiliary equation is 2s4 plus 12s square plus 16 equal to 0. For simplification, let me put s square is equal to z. That will be 2z square plus 12z plus 16 equal to 0. I am substituting this auxiliary equation equal to 0. So this will be z square plus 6z plus 8 should be equal to 0. Okay. Now this quadratic equation minus b plus minus under root of b square minus 4ac divided by 2a. So z in this case will be minus 6 plus minus under root of 36 minus 32 is 4. 8 4s are 32 and this is 2 minus 6 plus minus 2 divided by 2. That is minus 6 minus 2 is minus 8 by 2 and minus 6 plus 2 is minus 4 by 2 and this is minus 4 and minus 2. Let's see. Okay, fine. this is z value. But we have a z value, this is correct. Minus 6 minus 2 8 divided by 2 is 4. Okay, minus plus minus 4 divided by 2 is minus 2. So z is basically s square. S square is equal to minus 4. So s will be under root of minus 4, that will be plus minus j2 s value here, and then s square is also equal to minus 2, so s will be under root of minus 2, so s will be plus minus j under root of 2. So what we have got 4 non-repeated roots, that is plus minus j2 and plus minus j under root 2. Okay, this is very important. So we have got the roots plus minus j2 plus minus j under root 2. Now this is correct. Yeah. Now these are the roots of the characteristic equation. So they were responsible for, because we have rho was becoming prematurely 0. We substituted it to 0. We have got the roots. What are these roots? These roots have not got the real parts. You can say plus minus j2, no real part. Plus minus under root j2, no real part. What does this indicate? आपको कोई पता होना चाहिए. Then oscillation. So what will this indicate now? Fine, sinusoidal oscillation. Pure sinusoidal oscillations will be there. This should indicate what? This will indicate the sustained oscillations. So we will call them frequency of the sustained oscillations. So you write down this point. Thus the characteristic equation has 4 non-repeated roots on the j omega axis. This is procedure for this question answer. Later on you have to memorize it. Characteristic equation has 4 non-repeated roots on j omega axis and no roots with positive real parts. Characteristic equation has 4 non-repeated roots on the j omega axis and no roots with positive real parts. Hence the system under investigation is that. What is that? Marginally stable. Everything is on the imaginary axis. Hence the system under investigation is marginally stable system. So you have to remember when the stable system will be marginally. You cannot ascertain from the system from the roots you have to ascertain. Then once you are doing this, because rho is becoming prematurely 0, so assertion has to be done from the roots. Next, also the roots of the j omega axis indicate. Also the roots of the j omega axis indicate that the system has two frequency. That the system has two frequency of sustained oscillations. Two frequency of sustained oscillations of under root 2 radians per second, magnitude only 2 radians per second. So this has to be there. वहाँ हमने कुछ लिखा था पहले स्टेबल सिस्टम के. Since there are no sign change in the first column, the entire will carry no roots. Just cancel it. क्या लिखा था नहीं स्टेटमेंट हमने नहीं. We have just written. We have confirmed that there are no roots on the right half of S. Stable system नहीं आएगा. Just cancel it. But this is a clear-cut confirmation that there will be no roots of the right half of S plane. That doesn't indicate that the system is stable. So when this type of question will arise, you are not able to ascertain whether the system is stable or not, then you have to check the roots. Once you are checking the roots, if you are getting the pure imaginary roots, that itself indicates the system is marginally unstable. Next is first question we have from GATE 2000. GATE में लंबे क्वेश्चन नहीं आते. I'm always emphasizing on the same thing. You will not get bigger question, but you will get concept question. So that's why ये 2000 में आया. Okay. Have a look at your mobile phones. आपको समझ नहीं आ रहा? Are you not getting anything? We cannot ascertain or we cannot confirm that whether the system is stable or not. Although by row of zeros, whenever there is a row of zeros, there is always a doubt that we cannot confirm the system is stable. And we are not going, but we definitely can confirm that there are no roots on the right of capacity. But that doesn't indicate that the system is a stable system. Then how we have to go for the confirmation? We have to look at the roots, see that whether all the roots lie on the geometric axis, that confirms that the system is under investigation is a marginally stable system.
That's only one root lies on geometric axis or two.
No, every root should lie. That could be a direct question. This is not a question. Whosoever will frame a question, he is not a idiot. That you will land in a trouble that one is here and one is there. He is not going to land in the trouble. As of the question, you know that. Okay, anyway. Now the question is, have a look at the question. A system is described by the transfer function this. And he has given that that is a stable system. You have to find the constraints of alpha and x. What are the constraints? You have to find the root array and then you will see what are the limitations of these two. How much beyond we can do. See, most of the people, most of the students will think that okay, this is a negative feedback system, we will try to write a characteristic equation like this. This is completely wrong. He has not written anything about the system is negative, positive, nothing. He has given a system described by. When there is clearly given an instruction that system is described by a particular transfer function, you don't have to use your extra mind. You don't have to do anything. You have to just consider the denominator as the. This is the first time. Both are a confusion. Unless and until there is mentioned that you have a negative feedback control system, open loop control system, negative feedback control system, with an open loop control system with a negative feedback. Unless there is a mention specified in the question that this is the type of a question you have, then you have to use a characteristic equation. But if the questioner has not said anything, he has described a particular system and he is telling you about this system that you need to find so and so for this system, you have to consider the denominator itself. So you write down this point, it's a very important point. पहले ही क्वेश्चन गलत नहीं होना चाहिए. GS can be transfer function of open loop system. GS can be the transfer function of open loop system or closed loop system, comma, unless it can be a transfer function of open loop system, closed loop system, comma, unless it's mentioned in the question that negative feedback system, unless it is mentioned in the question that the negative feedback system exists, comma, till then characteristic equation will be denominator on. That means unless and until it is mentioned, fine, then you have to go for 1 plus g of h. It's not mentioned, for that characteristic equation will be denominator. So now, okay, now this question was just to get you familiar with the row of zeros. Now what he has asked, he has given us a transfer function and we will write the characteristic equation will be g of s, h of s in this case will not be there. So that's, this will be 2s cube, what is that? S cube plus alpha s square. This is the solution of this numerical. Alpha square plus ks plus 3. Okay, now form the roots array. S1, it will be K alpha minus 3 divided by alpha. Okay, that will be 0. And this has to be copied here on. This multiplied. This term multiplied by 3 minus 0 divided by this is 3. This term has to be copied all this. So what is the question? What are the constraints of alpha and 0? So he's giving us a clear-cut instruction that system is stable. So we don't have to worry. This is all positive, coefficient positive. This coefficient is positive. This coefficient is positive. This coefficient is positive. We know clearly from the question that while forming the root array, the first column, each entry in the first column of the roots array, the coefficients are positive. We are not worried. So what are the constraints now? Constraints are 2 only. Now this has to be greater than 0, and this K alpha minus 3 divided by alpha has to be greater than 0. That means K into alpha should be greater than 3. That means alpha should be greater than, or K alpha, you can write it like this. So what the options he has given? He has given 2 options. 4 options he will give. Out of them, one of the options will be alpha should be greater than 0, K alpha should be greater than 3. You have to just do it. This was a convention, a normal student can do it, and you can solve this like this. But make a note for the third order system. Most of the questions are asked in the gate examinations for third order system. Now, in a third order system, if you do not want to do this type of only, you can write a note. This is valid for a third order system. यानी हर एक system को लगाते जाओगे. यूनिट सर ने क्लास में कहा था बाद में. This is valid exclusively for the third order system. Now, what is valid for the third order system is that we can have 2 things: internal product, external product. See, internal product here means solution second for the third order system only. You don't have to do much hassle and much calculations if you are having a third order system. Now what is there? Internal product. I will call this internal product as IP. Internal product will be the multiplication of the coefficients of the internal 2 terms, that is K alpha. External product that is XP, what XP? EP will be the multiplication of the external coefficients of external term. The coefficient of x cube is 1 and coefficient here is 3. So that will be 3. It should be very clear. So that means we have to multiply this. This indicates internal product. Coefficient of this, which is 1, external product. Coefficients have to be considered. Okay. Then what are the 3 things? Out of these things, if internal product is greater than the external product, system is stable. If internal product is less than the external product, system is unstable. If they are both equal, system is marginally stable. So next you can write down. So IP in our case is alpha K or K alpha. EP is 3. Number 1 condition is internal product is greater than external product, then system under investigation is a stable system. If second condition is internal product is less than external product, then system is unstable. Third, if internal product is equal to external product, then system is marginally stable. So if in a gate exam the question is asked whether the system is stable, within a second you can find for the third order system. This is the one. Okay, what in our case is system is already given stable. What is internal product? So alpha K is greater than 3. This confirms from the statement also. You don't have a calculation. You have to just see the constraints. Alpha k should be greater than 0, and others will be alpha itself will be greater than 0. But if the question has been asked, our question can be framed like this, constraint question can be framed like this, whether the system is stable. You don't have to do much calculation. You should remember these three internal product for a third order system. Okay, so this was for this question. Next question is in GATE 2008. This question has been asked. Very good question also. So next question is the number of poles. Have a look at your mobile phone. You can chat it down here. The number of mobile phones. Number of mobile phones are 34. Right? The number of open loop poles of RH right half plane. Okay. The number of open loop poles of right half plane. As plane is also called, plane is also called. There is no difference in this. Poles of G of S is given. So he has given open loop poles. So you have to find number of poles for this only. No characteristic equation 1 plus G of S. That has not to be done. Whatever has been asked, you have to find for that. So denominator very clearly is the characteristic equation. What you are going to do? You are going to take a denominator, find the roots array, and then how we can say that number of poles, how we can say that number of poles on the RH side? Once you find the root array, then what you do? You will see the number of sign change. The number of sign change exactly. Do it within 1 minute. You should be able to do this question. ये तो बिल्कुल कोई क्वेश्चन है ही नहीं. This is a very simple question. A layman can do it. So characteristic equation is given. You do it yourself. Let me do it. The denominator will be S is power 5. S is power 4 plus 3s cube plus 6x square plus 5s plus 3. One, 3, and 5. 2, 6, and 3. So 0 has to be replaced by epsilon. Epsilon between epsilon times 2. Okay. So what is there now? 6 epsilon minus 7 divided by epsilon. Next 3 epsilon minus 0 divided by epsilon is 3. Epsilon minus 0 divided by epsilon is 3. Next is 6 epsilon minus 7 divided by epsilon into 7
Sir.
by 2.
सर
Yes.
किया था सर
हाँ?
किया था परसों
Yeah?
किया था परसों
ये किया था आपने? अच्छा, ये show of zeros में आया हुआ है. This is not a row of zeros. Anyway, this we have done and fine. We'll move on. But in this case, only you have to find number of sign changes, so that will be 2. System is unstable. Anyway, let's move to next question. This is another GATE question. क्योंकि हमने पहले में किया होगा ना ये. This is not a row of 0 question. Anyway, let's move. Now, what is given in the question? The feedback system shown below oscillates at 2 radians per second. feedback system has been shown. Now this feedback system is given. This is very clear question. Feedback system shown below oscillates at 2 radians per second when we have been given the system. Find the value of k and a. So what is the 2 means? They are shown oscillates at 2. There are 2 roots that are non-repeated roots, and they will lie on the which axis? They will lie on the imaginary axis. So frequency of oscillation is given. That is 2 radians per second. So let me draw the graph for the explanation's sake. This is your j omega minus j omega. This is your real axis sigma. Now what are these? J2 and j minus 2. So j2 will be, let's say, somewhere here, and j minus 2 will be here, and this is your S2. So this has been given in the question. Now in the question, we have been given the transfer function, and this very clearly is a negative feedback system. So we have to find now characteristic equation. You do it, whosoever knows it, they can do it on their own. Don't have to wait for anything. But you have complete concept from, you can do it of your own and just share the answer. Okay. So next, the characteristic equation of the feedback system is given as g of s, h of s is equal to 0. 1 plus g of s will be equal to 0 because h of s is a unity to negative feedback system. So what will be h of g of s? G of s is given. What's that? K s plus 1 divided by, then you have s cube plus as square plus 2s plus 1. That should be equal to 0. So we can write it here. That will be s cube plus as square plus 2s plus 1 plus k s plus k will be equal to 0. Now collecting the right terms, k square, s is there, so k plus 2 into s, and then we have k plus 1. So this is your characteristic. Now what we have to form? We have to form the ROUTH array. After the ROUTH array, the frequency of oscillations is given to us. I will make a note for that. Let's form the ROUTH array first. Forming s cube, s square. So first term is 1. Here it is 1 k plus 2. This is 1 k plus 2. This is a and k plus 1. Okay. So s1 will be a into k plus 1 minus k plus 2. K plus 2 minus k plus 1 divided by a. Okay. Next term will be 0. Okay. S naught will be, this will be copied here. This multiplied by this minus 0 divided by this is k plus 1. So can anybody tell me how we have to proceed hereafter? Shabash. See, he has not given any feedback. He has given, intentionally he has given the frequency of oscillation. There is a purpose behind it. Any shabash? What is the frequency of oscillation? The question I have shown you at the beginning, there was always a purpose behind it. Question we have chosen at the beginning, there was always a पर्पस बिहाइंड इट, ठीक है, कोई चीज पर्पस के बिना नहीं होती. Now we can make a note. Frequency of oscillations are related to rho of 0, ROZ we call it. Frequency of oscillations are related to rho of 0. Once they are related, then only the oscillations, then only the frequency of oscillations will exist. So, a questioner or an IIT professor knows that a student knows that rho of 0 will exist only, it will exist only when it will exist, then the frequency of sustained oscillations will be there. Unless and until frequency of sustained oscillations will not be there, no rho of 0 will exist. Both are conversely to each other. So professor knows itself that I have given the sustained oscillations frequency, a student has to know that rho of 0 will exist. It's very clear. So that you have to know. So it should be very clear that rho of 0 will exist, and then only the sustained frequency of sustained oscillations are going to exist. It's the other way around. Okay, when this will exist, where will it? Now the question next is where the rho of 0 is going to exist. शाबाश सुब्बा, अभी मैंने बताया. It will always exist. इसमें कोई पूछने की चीज है ही नहीं. Whenever he also knows the location where the rho of 0 will be. So rho of 0 definitely should be here. It will be at the odd location. He has given you the sustained oscillations. There is a purpose behind it. Second, because you should know that once the sustained oscillations values are given, the rho of 0 will exist. If he has given the rho of 0 exists, you know rho of 0 will exist, ROZ will exist, then you yourself will know where is the location. Location will be always 0. Okay? When the rho of 0 will exist, what will happen? So, that means this is the auxiliary equation. This is the auxiliary equation A, Z plus 2, whatever it is. This should be an auxiliary equation. Okay? So, you can write down rho of 0 exists for odd powers of S. So we find roots. How we find roots? We find it by substituting it equal to 0. Substitute the rho of 0 equal to 0. A k plus 2 minus k plus 1 is equal to 0. So that means A k plus 2 is equal to k plus 1. So A value we can get it from here is k plus 1 divided by k plus 2. That's called equation number 1. Now this is the one, but we have two unknowns. Okay? Now roots of the auxiliary equation are what? Frequency of sustained oscillations. So what is our auxiliary equation? Auxiliary equation is what? Auxiliary equation is this one. This is rho of 0, sorry. We are talking about the rho of 0. Fine. Then this is auxiliary. Auxiliary equation will be AS square plus, second is K of K1 plus, odd में होगा ना, AS square plus K plus 1, S is for 0. So that will be, and K is for 0 is 1. Next you can write down, above rho of 0 will exist odd. That is very clear, that has gone now. Now where is the auxiliary equation? Auxiliary equation you can write down, the above rho of 0 is called, above rho of 0 represents above rho of 0 represents the auxiliary equation. Auxiliary equation will be given as A of S will be equal to, this is AS square plus coefficient of this is A plus 1, S is for Z. Now what will happen? What are the roots of auxiliary equation, Shabash? Roots of auxiliary equation are what? The roots of auxiliary equation are frequency, we can write down. Also we know that roots of the auxiliary equations are frequency of oscillations. Hence, S will be equal to, क्या दिया था इसने? Plus minus J2 ही दिया था ना इसने, तो S स्क्वायर क्या होगा हमारे पास, दोनों प्लस, अगर हम J2 का होल स्क्वायर लेंगे तो प्लस प्लस J स्क्वायर अंडर रूट ऑफ 1 माइनस विल बी अंडर रूट ऑफ 1 माइनस स्क्वायर 2 का स्क्वायर क्या हो गया, माइनस माइनस 4 हो गया ये। अगर आप दूसरा भी लेंगे, दूसरे का स्क्वायर भी करेंगे, किसका, माइनस वाले का, J का, माइनस माइनस विल बी प्लस, दिस विल बी माइनस 4, from both sides you are going to get minus 4 S square. ऐसा क्वेश्चन चूज किया है तो क्वेश्चन will be in such a way that you will not be confused at any stage. Sometimes it can happen, होता है, आदमी से आगे होता है, लेकिन now see the question is like that whenever we are taking the S square, both times it's coming minus 4. Where we need the S square? We need the S square where we need it in the auxiliary equation. So next you can write down from equation, ये जो equation हमने लिखी थी ना, okay, a square, और हमने लिखी थी equation कौन सी, second लिखते हैं इसको। So from we can substitute this for roots, क्या हम करते हैं, इसको substitute 0 करते हैं, तो a s square की वैल्यू क्या है हमारे पास, minus 4a plus a plus 1 should be equal to 0 from equation second, ठीक है। So minus 4a will be equal to minus k plus 1, a will be equal to minus k plus 1 divided by 4, that's called equation third. So in both the cases a has to be same, है ना, minus will get cancelled, है ना, minus, okay, in both the cases a has to be same, so equating 1 and third, so k plus 1 divided by k plus 2 should be equal to k plus 1 divided by 4, so k plus 2 is equal to 4, so k is equal to 2, ठीक है, so k is equal to 2. So what should be the value of a now? A should be, any of the equation we can substitute. A will be 3 by 4, that's 0.75. So K should be 2, A should be 0.75. Then take that option. See, very well framed question this was. What he has given, I will again repeat it. The examiner has given what? He has given a negative feedback control system where you should know the auxiliary equation, where you should know the characteristic equation. How is that? 1 plus g of s, h of s is equal to 1. H of s is 1, so 1 plus g of s you have to get it. You have got it, you have formed the roots array. Once you have formed the root array, he has given this frequency of the sustained oscillations. Okay, so frequency of sustained oscillations will exist only when there will be a rho of 0. Rho of 0 will exist where we have odd powers, so it will exist here. So once you have got the rho of 0, above the rho of 0 there will be an auxiliary equation. Substitute that auxiliary equation in the 0 and get the value of this a from the row of zeros, equate both of them, putting it equal to value of the sustained oscillations, equate both of them, you will get the value of both the constants. So very nicely framed question. One has to understand 2-3 things you have to remember, rest of all will come exam. Okay, time?
5 minutes.
Last question, one more question is there. Gate 2016, this has been asked. See, this is also a very good question. Probably. Okay. The transfer function has been given. What is the transfer function that has been given? And it has not been mentioned, it's a negative feedback or a positive feedback, that means that denominator itself will be considered as a characteristic equation. But what is the question? Transfer function GP of S is given with P as a positive parameter. So P value has to be positive. The maximum value of P until the GP remains stable. So GP has to remain stable. It has to remain stable. Then what should be the maximum value of P? 4 options are there. Okay. First question, you form the ROUTH array. Characteristic equation of the GPS will be what is that? That is given. That is S square plus 3 plus P into S plus 2 minus P. 2 minus P. Okay, you form the ROUTH array. I'm not writing, but it's very clear. S square is called 1. This is first term is what? 3 plus P, and then we have 2 minus P. Okay, sorry. 1, 2 minus P, fine. Okay, then we have 3 plus P, and then we have 0. So S of 0 will be 3 plus P into 2 minus P. Okay. Minus 0 divided by 3 plus P, this will be 2. 2 minus P. First ROUTH array is formed like this. Very nice. So what the question he is asking? He is telling, if this has to be stable, what should be the condition? All the terms in the first column of the ROUTH array has to be positive. That is very clear. Okay. What should be positive then? We know 1 is positive. 3 plus P is positive, fine. 2 minus P is positive, fine. For GPS to be, you can write down. For GPS system to be stable, conditions are. For GPS system to be stable, what are the conditions? 3 plus P should be greater than 0, everybody knows. So that means what? P should be greater than minus 3. 2 minus P should be greater than 0, minus P should be greater than minus 2, but if we have to change the signs, then the inequalities will change. This is the rule of mathematics, we should know, elementary. So what should be the range? Range of stability. Sometimes this can be asked in the examination. Range should start from minus 3 should be less than P should be less than 2. It exists between 3 and 2. Okay, now the question exists, see what the question he has asked. The maximum value of P until the GP remains stable. So maximum value of G can have a range, maximum value, and G is a positive number, he has given, he is not a negative number. So range of this has to be Z, it should be less than. So P value has to lie between range. If he is asking, he can ask sometimes the range, this is the answer. But if he is asking the maximum value of P, since P has been given as positive, then the maximum value of P max is 2. Very simple question. Just the concepts are there. You have to use your mind, you can answer. Very simple. 2 things he can ask. Number 1, range he can ask. The range, complete range is this. Then he can ask the range of P. Where from the P will lie if P is positive. He has already given P is positive, so that can lie from here to there. Then he has given what is the maximum value of P, and maximum value of P has to be. That's fine. So one more question we have, but we have time. Anyway, we'll continue. We have some one or two not difficult numericals, but very simple numericals.
सर इसको स्टॉप करें